Today we're going to talk about polynomials, and what you're looking at right now is the definition of a polynomial. And if you notice, it talks about degree n. Degree is the highest exponent that you see in your polynomial. Now this exponent could be in the leading term or the first term, or it could be in any term, so make sure you look throughout the polynomial. What else is important about this definition is the words non-negative integer. The degree must be non-negative. The exponents must be non-negative. So if you have a negative, that brings it down and makes it a fraction, and this is no longer a polynomial. Now all the terms have coefficients. And the leading coefficient is important because it tells you a lot about the graph. And the leading coefficient is the number in front of that highest exponent term. So this would be our leading coefficient right here. Now, there's also one other piece that I want to talk about, and that is the constant term. The constant term is the term that has no x or no variable attached to it. In this, it's right here. This is our constant. And the constant term tells you your y-intercept. So it's handy. So just remember the constant term gives you your y-intercept, or where your graph crosses the y-axis. All right, so let's look at an example and identify these three important pieces of that polynomial. So right here you see an example, 3x to the fourth plus 5x cubed minus 2x to the seventh minus 15x plus 3. And so first we're going to look for the highest exponent. It is not in descending order. This is your degree. So if that is your degree, your leading coefficient is -2. And your constant is 3. So your y-intercept is at 3. Now let's talk about the graphs of polynomial functions. Graphs of polynomial functions are smooth and continuous everywhere. So you should be able to draw them without picking up your pencil. They're very pretty graphs. There are no breaks or holes or harsh turns. And anyway, they're very pretty and fun to graph. Domain is also all real numbers in polynomials. You can also determine a lot from the turning points of a graph. This particular graph has 2 turning points. So I could guess my degree and say that it's probably going to be a third degree polynomial, because an nth degree polynomial has at most n minus 1 turning points, turns in the graph. Okay, so this one right here has 1, 2, 3 turns. So we could make an educated guess and say this is possibly a 4th degree polynomial. Sometimes turns disappear, and so you don't have exactly n minus 1 turns or degree minus 1 turns, but it is a good educated guess that you can make.